Hello Gators, this is 6.10, integrating functions using long division and completing the square, and 6.14, a summary of all the techniques we've had. Let's go ahead and start by integrating using long division. Let's take a look at this rational expression that we have. We have a numerator and a denominator, and the numerator is improper. It has a greater degree than the denominator. So we can use long division to help us write it in a proper fraction form. So we're going to take x minus 2, write it in this long division form. We'll take the first term, 3x cubed, and divide it by the first term in the binomial, and we'll get 3x squared. So I'm going to put 3x squared here on top of the x squared column, and then I'm going to take 3x squared, I'm going to multiply it over here, 3x cubed minus 6x squared, and then I want to go ahead and change signs because I want to subtract. So subtract, and then subtract is going to be an adding situation. And then I'm going to add, and I'm going to have 5x squared, bring down the next term, negative 5x. Now I'm going to take this term, 5x squared, and I'm going to divide it by the first term in the binomial, and that'll be 5x. So I'm going to put plus 5x up here in the answer portion, multiply, which is 5x squared minus 10x. Now to subtract, I need to subtract, which means changing the sign. And now I'm going to have a 5x plus 1. And then I'm going to take 5x and divide it by x, and that'll be 5. So this will be plus 5, and that'll be 5x minus 10. And again, I'm going to subtract, minus, plus, and then I'm going to have a remainder of 9. And the way we put remainder is plus 9 over x minus 2. All right, so now I can rewrite this in two integrals. I can write it in this integral right here, 3x squared plus 5x plus 5, and dx plus, and then the integral of the fraction, which is 9 over x minus 2 dx. And I can find the antiderivative of this. This will be x cubed plus 5x squared over 2 plus 5x. And then over here, I'm going to have to use u substitution. I'm going to let u be equal to x minus 2, and du will be equal to dx. So this is going to be plus integral, and I can bring the 9 outside, and this will be du over u. And so now I'll have x cubed plus 5x squared over 2 plus 5x plus 9 natural log of the absolute value of u plus c. And then our last step is to resubstitute for the u and make it 9 natural log of the absolute value of x minus 2 plus c. So the lesson to be learned here is we take an improper fraction, make it proper, and the answer part will be something that a polynomial that we can integrate, and the remainder will be an application of the natural log. All right, let's take a look at another problem. And again, this is improper, and I've just started dividing here. I've done the first step here, and I've gotten this. So 3x cubed divided by 3x is going to be x squared. So this is going to be plus x squared. And then this will be 3x cubed minus 5x squared. And then I want to change signs, which means I'm subtracting. And then I'm going to get 6x squared plus 2x. And when I take 6x squared and divide it by 3x, I'm going to get 2x. So this will be plus 2x. And so this is 6x squared minus 10x. And again, I need to subtract. And that'll be 12x plus, bring down the next term, 0. 12x divided by 3x is equal to 4. So this will be plus 4, and that'll be 12x minus 20. And again, I'm going to change signs. That's subtracting, and then I'm going to have a 20. So this will be plus 20 over 3x minus 5. So now I can rewrite this as a proper fraction. I'll have the answer portion in one integral, x cubed plus x squared plus 2x plus 4 dx, plus, and then the integral of the remainder, 20 over 3x minus 5 dx. The reason I'm putting it in two integrals is one integral is just power rule and the other integral is natural log, and that's why I'm separating them. So this is now going to be 2x to the fourth power over 4 plus x cubed over 3 plus x squared plus 14x. And now I'm going to let u be equal to 3x minus 5, and du will be equal to 3 dx. So dx is equal to du over 3. So this will be plus 20. I'll pull the 20 out. And then I'll have a du over 3 divided by u. And I'll take that 3 out of here and put it over here so that I'll have a du over u. And now I'm going to have x to the fourth over 2 plus x cubed over 3 plus x squared plus 14x plus 20 thirds natural log of absolute value of u plus c. And then we have just one more step, and that step is to resubstitute for our u. And then this will be the natural log of the absolute value of 3x minus 5 plus c. All right, let's take a look at another algebra operation that we do quite often, and that's called completing the square. To complete the square, what we want to do is we want to take the first two terms and kind of move the 7 over. And to complete the square, what we do is we take half of this term, which is 3, and then we square it. So take half of the 6 and then square it, and that answer is 9. So we want to add 9 to complete the square. But if we're going to add 9, we need to subtract 9 so that we don't change the problem. Okay, I'll subtract this. I'll erase this work right here so I can have some room. And now I'm going to rewrite this, and this will be x plus 3, that's the square, and then minus 2. And so this is called completing a square so that you can get this square term. All right, let's go ahead and do this again. X squared minus 4x, and then I'll write plus 1. And now I'm going to take half of this term. I'm going to take negative 4 and divide it by 2 and then square it. And so that'll be 4. So I'm going to add a 4, but if I add a 4, I need to subtract a 4 so I don't change the expression. And so then this can be written as x minus 2 squared. So now I have a square, and then minus 3. And so this is how we go about completing the square. Okay, how could that be an advantage to us in integration? Well, right here, it's going to be hard to integrate this right now. But if we complete the square, and you can see I pushed the 10 over, I added 9, I completed the square, minus 9, and now I have this expression. So now this can be written as a dx all over x plus 3 squared plus 1. This looks a lot like a tan inverse, so I'm going to go through a u substitution. U equals x plus 3, du equals dx. So this can be written as du all over u squared plus 1. And now that can be written as tan inverse u plus c. And then I'll go back to substituting for my u, and that'll be x plus 3 plus c. So it's an advantage to rewrite this trinomial into a perfect square and make it look more like a binomial. All right, let's do it again. And you can see we have a negative in front here. So I went ahead and pushed the negative 15 over there. I factored out the negative 1, and I took half of this term and then squared it. That's 16. I really didn't add 16. I really subtracted 16, so I have to add 16 to this side so I don't change anything. Now this is a perfect square. This is plus 1, and I can rewrite it this way. So let me go ahead and do that. And so this is going to be a 1 over square root of 1 minus x minus 4 squared. So we can rewrite it. And now I'm going to go through my u substitution. Let u be equal to x minus 4. du equals dx. So now this can be written as, oh, I forgot my dx here. So now this is going to be du all over root 1 minus u squared. And we know that is a trig inverse. And then I can resubstitute for my u and put in x minus 4. Okay, last one, and last one's going to take some algebra here, so let's go ahead and go through this. I'm going to push my 20 over to the other side, and then I'm going to complete my square, and now I have this. But unfortunately, this looks like it's a wannabe tan inverse, but I don't have a 1 here. So what I'm going to do is use some algebra. I'm going to divide the numerator and the denominator by 16. I'm going to divide all terms by 16. And so this is going to end up being a 2 dx. And then this is going to be, I can rewrite this as x minus 2 over 4 squared plus 1. So I could move this 2 out here, and then I'll go ahead and erase the 2 here. And so now I could go through my u substitution. Let u be equal to x minus 2 over 4. Or you can just say x over 4 minus 1/2. And du will be equal to 1/4 dx. So dx is equal to 4 du. All right, let me go ahead and substitute. So this will be 2 integral 4 du over u squared plus 1. And I'm going to bring that 4 over to the other side. And when I do that, it'll now be 8. Okay, so now this will be 8 tan inverse of u plus c. And then I substitute for my u, and my u is x minus 2 over 4 plus c. All right, let's see if you can stop the screencast and see if you can remember all the techniques we use for finding antiderivatives here. And here are the answers. The power rule, antiderivative, u substitution, recognizing a trig inverse, recognizing trigonometry, how to use that, exponential and logarithms, long division, and completing the square. This is the end of the screencast.